Alright, now move to the last concept about an acid and a base, which is Lewis concept. Okay, unlike Arrhenius and Brusselori that delimit an acid to be a substance that have proton ion, that's hydrogen ion or proton. Lewis concept about an acid is the opposite. Okay, yes, it didn't limit an acid to be a substance that must have hydrogen ion first before you can know that that substance is an acid. There are associated substances that are acid, but they don't have hydrogen ion. Okay, so Lewis concept talk about such substance. Okay, now Lewis he defined an acid to be a substance that accept electron pair. Yes, that accept electron pair. In other words, an acid is an electron pair acceptor. Yes, we find an acid to be a substance that is an electron pair acceptor. While a base, then why a base to be what? An electron pair donor. Okay, yes, an electron pair donor. Okay, please take note of this electron pair. Okay, pair means two. Okay, yes. So an acid is it defines an acid to be a substance that accept pair of electron, while a base to be a substance that would donate pairs of electron. Must be pair. Okay, yes. Now before I continue, let me first tell you guys, let me to make it, because most students find it difficult to understand this concept. Now before I continue, let me take you guys back to O level. This is what we call Lewis dot structure. You guys need to understand this first before I can continue. Lewis dot structure. This law was stated by Lewis. Now this law state that an atom said that an element is represented by its symbol. Say that an element or an atom is represented by what? Is represented by a symbol. Surrounding the symbol is the valence. I'm using nitrogen as an example. What is the valence electron of nitrogen? The valence electron of nitrogen is 5. Okay, yes. Now, Lewis structure state that the symbol of an element is used to represent the nucleus of that element and the innermost electron. Okay, yes. This law said that okay, an element, okay, said that the symbol of an element represent the nucleus of that element and what? The innermost electron of that element. Okay, yes. Then surrounding the four corner of that element is the valence electron of that element. Now, let's use nitrogen as an example. What is the valence electron of nitrogen? It's what? 5. So Lewis dot structure tells us that we will take the symbol of an element, we will use this, we will take the symbol of an element to be the nucleus and what the innermost electron. Then while the outermost electron, we will arrange it around the four corner of the symbol of that element. I don't know if you understand. Now we are taking nitrogen as an example. The symbol of this N represents the nucleus and the innermost electron of what? Of nitrogen. Then the outermost electron, which is the valence electron, are arranged in the four corners of the symbol. Okay, that is Lewis dot structure for you. State that the symbol of an element represents the nucleus and the innermost electron of that element. Surrounding the four corners of that symbol is the outermost electron. Okay, yes. So what is the valence electron of outermost electron? Still means valence electron. What is the valence electron of nitrogen? The valence electron of nitrogen is 5. So we arrange the 5 electron as dots. That's why it calls the Lewis dot structure as dots. We arrange it in the four corner. This is 1, 2, 3, 4. Now I say that when there are still more electron, we start to what? We start to pair. That is 5. Okay. This is 1, 2, 3, 4, 5. Okay. So this is what Lewis dot structure is saying. It's saying that the symbol of an element represent the nucleus and innermost electron of the element. Surrounding that symbol of that element is the valence electron arranged in the four corners of that symbol. Okay, yes. Let's use oxygen as an example. Oxygen has 6 valence electron, abi? Yes. So we do like this. Draw with this oxygen, the symbol for oxygen is O. Yes. Now this O represents what? The nucleus of oxygen and what's the innermost electron of oxygen. Okay, yes. Then we need to arrange the valence electron in the four corners of what? Of this symbol. Okay, now oxygen has 6 valence electrons, so we start from here: 1, 2, 3, 4. The electron still remains 2, so we start to what? To pair 5 and what? 6. Okay, yes. So this is what Lewis structure is saying, that the symbol of an element represents the nucleus and innermost electron of that element, while surrounding the symbol of that element is the valence electrons of what? Of that element. Okay, arranged at the four corner of the symbol of the element. Okay, yes. So if we even use fluorine, fluorine has 7 as its valence electron. This is fluorine. So now be 1, 2, 3, 4, 5, 6, 7, as the case may be. Okay, yes. So this is Lewis dot structure. Now, before I continue, eh? Before I continue, nitrogen has what? 5 valence electron, abi? We need to arrange the 5 valence electron in the four corners of this symbol, which is 1, 2, 3, 4, then what? 5. Now let's continue. Take note that this place here, these two electrons that are banded together, is called what? It's called a lone pair. It's called a lone pair. While these that are not banded at all, these electrons that are not banded are called what? They are all called what? Odd pair. Okay, yes. Now let's go back. Let's go back to the Lewis concept about an acid. Lewis defined an acid to be what? To be an electron pair acceptor. An acid accept pair of electron. An acid accept pair of electron. Then Lewis also defined a base to be a substance that what? That donate pair. There must be pair. That donate what? Pair of what? Pair of electron. Okay? Yes. Now I told you guys that according to Lewis dot structure, the symbol of an element represents the innermost electron of the element and the nucleus of the element. Surrounding the symbol are the valence electron of the element arranged in the four corners. Okay? Yes. Now I told you guys that the the electrons that are banded here are called a lone pair. Yeah, the ones that are banded are called a lone pair. While the ones that are alone, that are not banded, are called what? Odd pair. Now you can use this. See that how many lone pair does nitrogen has? Nitrogen has what? One lone pair and what? 3 odd pair. Then what about oxygen? What is the valence electron for oxygen? It's 6. So we will arrange it 1, 2, 3, 4, 5, 6. You find out that oxygen has what? 2 lone pair and 2 odd pair. Okay, yes. Now let's go back to Lewis dot structure. Okay, you will know why I do this. Okay, now let's continue. Okay, now Lewis defined an acid to be what? Electron pair what? Electron pair acceptor. Okay, yes. Why a base to be what? Electron pair what? Do no. Now it didn't limit an acid to be a substance that must dissolve in water first. It didn't limit an acid to be a substance that it didn't limit to be a substance that has proton, that has hydrogen ion. Okay, yes. So Lewis concept is above that. Okay, now let's do something now. This is nitrogen. This is nitrogen. Okay, this is nitrogen. Okay, I'm coming. This is ammonia. Uh, Before then, yeah, according to Lewis dot structure, when it told us that the symbol of an element represents the nucleus and the electron of that element and the innermost electron of that element. Surrounding the symbol of the element are the valence electron. Nitrogen has valence electron, 5 valence electrons. So 1, 2, 3, 4, 5. Yes. Now nitrogen cannot use this again to react with hydrogen to form ammonia. No, because this electron is already banded. Now it can use this to react with other substance. When you use this to react with hydrogen, you use this to react with hydrogen, it forms what? It forms ammonia. Hydrogen has one electron. Hydrogen brings his own electron and bond with this one. Hydrogen brings his own electron and bond with this one. Hydrogen brings his own electron and bond with this one. So together they form what? Ammonia. Yes. Now let's continue. Ammonia, this is in your textbook. Ammonia reacting with boron chloride. Now let's use the Lewis dot structure again. Boron trichloride, I meant to say. What am I saying? Yeah, boron trichloride. Yes. Now, boron has what? Hydrogen, helium, lithium, boron. Boron has 3 valence electron. Yes. Boron has what? 3 valence electron. Okay. Yeah, it has 3 valence electron. Now, if you do it according to Lewis dot structure, you see, we get something like this: 1, 2, 3. Yes, get something like this with 1, 2, 3, because it has 3 valence electron. Okay, yes. Now, boron can use this to react with what? Okay, let me just do it to be in a good to be in a symmetrical manner. 1, 2, 3, still the same thing. So use this to react with chlorine, use this to react with another chlorine, use this to react with another chlorine. Okay, yes. That is, chlorine brings its own electron to bond with this one. This other chlorine brings its own electron to bond with this one. This other chlorine brings its own electron to bond with what? Bring to bond with this electron. I be yes. Now with this what? This is boron trichloride. Why this is what? Ammonia. Yes. Now, eh? Now, Lewis concept about an acid. He defined an acid to be what? If you check this in your textbook, there's something like this in your textbook. Yes. If you check in your textbook, yeah, ammonia reacting with boron trichloride. I mean, boron trichloride, if I'm not mistaken. Yeah. So now, which of these substance is a Lewis acid, and which of these substance is a Lewis base? Now, let me just give you a clue. Substance that have many electrons, that has large amount of electron, is a Lewis base, because according to Lewis, a base is substance that donates pair of electron. Yes. Why a substance that does not have many electron is what? Is a Lewis acid. They have to tell you that positive ions, I'm coming, positive ions, yeah, positive ions, they have already lose electron. Yes. Therefore, all these guys are what? They are Lewis acid. I'm using this as an example because Lewis acid, they accept electron. These ones, they cannot donate electron because they have already donate electron. So they can easily accept electron. Okay, now let's go back to this one. Okay, so this is ammonia reacting with boron trifluoride. Now, which of these is Lewis base and which of these is Lewis acid? Now, where is Lewis base? A Lewis base is a base that would donate pair of that it donate what? Pair of what? Pair of electron. Now, if you look at this structure, which one um can easily donate electron, that it can easily donate a pair of electron? Is it this? This one can no longer donate electron again. This because it has already used all its electron to what? To bond with chlorine. But if you look at this guy, look at ammonia, you find out that it uses some of its electron to bond with hydrogen. It still remains 2 electron up here. So remember, pair means 2. So this is what is the Lewis base, because why? It will donate these 2 electron to what? To this guy. I don't know if you understand. It will donate these 2 electron to this guy. So in this process, this is what? The Lewis base, while this is what? The Lewis acid. This because here this boron trichloride accept pair of electron. Pair means 2. Pair of electron from where? From ammonia. Yes. In the end of the day, ammonia is what? Is Lewis base because it donates pair of electron. Yeah, while boron trichloride is Lewis acid because it accepts pair of electron. Now, what about this? Let me be fast. What about this? O2 minus. O2 minus, is it a Lewis base or is it Lewis acid? O2 minus, it means that it has already accepted two electron already. I don't even understand. It means that it has already accepted two electron already. Two minus accept, okay? Yes. This will tell you that it has more electron. Yeah. It's capable of losing, giving out electron. I don't even understand. Yes. So therefore, O2 minus is a Lewis base because it has many electrons. I don't even understand. It's capable of what? Donating two electron. Yes. It's capable of donating two electron. Okay. Yes. So that is all about Lewis concept about acid and base. Yeah. Just understand Lewis dot structure. With Lewis dot structure, you can easily tell which, if that is for some complicated compound. Yes, you can easily tell which is a Lewis base and which is a Lewis acid. Yes. So that is just it. Okay. That is just it. Even proton reacting with ammonia. Come here, ammonia. Now proton reacting with ammonia. Yes. Proton here, is it an acid or is it a Lewis acid or Lewis base? It is what is it is a Lewis acid because why? E accept pair of electron from where? From ammonia abi? Yes. In process this Lewis base, this is Lewis acid. Yes. So Lewis acid dey what do dey accept pair of electron, while Lewis base dey what donate pair of electron. Okay, so that is it about acid and base. Thank you.